This meeting is being live streamed. It always makes me look dumb, this part, because it doesn't make it obvious when it actually goes live. So I'm kind of looking vacantly at the screen half the time, and actually it's already gone live, which is like that. But either way, thanks so much for coming along to tonight's Knots IoT. Before we get going, as always, spoilers, we run a safe meetup and we like to make sure it stays that way. So if there's a lot of words on there, but basically it just means be nice to everybody. If anybody doesn't feel as though somebody is standing by our code of conduct, then the easiest way to remedy that is just to contact me in the direct messages in Zoom. If you send me a message, I'll make sure that you're fully informed of the process that we take after that. But if you'd be nice, then we shouldn't have any problems. But I know you all anyway, so you're all nice folks. It's all good. If you want to know a little bit more about it, then you can go to that bit.ly down there, Knots IoT Be Nice, and you can find out a bit more. Now, tonight, we've got a new sponsor, which the eagle-eyed of you at the top of the first slide will have spotted. But Calix, which they are a medical research company based in Nottingham. They do all sorts of stuff with tech and AI in the medical research arena. So we're quite excited to have them on board. And they're actually going to be sponsoring us around 50 quid's worth of IoT kit every month. So one of you lucky folks here tonight may well win a £50 worth of IoT kit that Cliff will choose, most likely from the Pi Hut or Pi Moroni. So yeah, it's quite exciting, quite happy about that. There'll be another announcement for other meetup groups coming tomorrow as well, so keep your eyes out about that. So thanks so much to Calix. Obviously we've still got my company on there, even though I'm now gainfully employed, and Tech Nottingham for sponsoring us a Zoom license, JetBrains for sponsoring us one of their products, and then now Calix for our monthly IoT giveaways. That's fantastic. Tech Nottingham, they're a Nottingham-based, but now worldwide, like every meetup group. Slack is their main location, so you can go and join their Slack community on there. They've got channels from the regular general stuff all the way through programming languages and sewing, knitting, gardening, counting up in nines, whatever you want to do on there, pretty much everything on there. But well worth joining. There's a whole heap of like-minded people there, and they really are a wonderful community. JetBrains, as I mentioned, they're sponsoring us a 12-month license to one of their fabulous products. They are they make developer tools for developers, so everything from JetBrains through Rider and IntelliJ and PHP Storm, WebStorm, something like that. Yeah, so they make a whole heap of really cool stuff, well worth getting. So if you tweet on the hashtag NotsIoT tonight, then not only could you win a JetBrains license, but you also may well win £50 worth of IoT kit, thanks to Calix and JetBrains for that. And tonight we've got the awesome Cliff Agius. It always makes me sort of go, that's not what you do, or it's not all you do, when I read what it says underneath his name there. But actually, that is what you do. You're just that good that you do something else as well, which is indicated by that lovely photo of Cliff by the side of it. But yeah, Cliff's going to be talking about ESP32 and the Wilderness Labs Meadow F7 device. And what cool stuff that you can do with them, and certainly what you can do with .NET with those as well these days. So looking forward to that. Coming up, we've not got one in April because I'm actually going to be away on holiday with my family for the 2 weeks that I would have normally had this meetup. And actually, when I look today, that date in May, I'm actually going to be in London at NBC. But I think I'll probably be able to do it from the hotel room because Lauren Ellerbach is awesome. Lauren's the principal software engineer at Microsoft, and he's got his hands in all sorts of IoT stuff. So he'll be following on from what Cliff's talking tonight about .NET Nano Framework and what cool stuff you can do with that. So Thursday, the 12th of May for that one, from all the way from London and Seattle, I believe he'll be. So awesome. At the end of this month as well, we've got Clyde Davies at .NET Knots talking about Chem for Word. So they've made, I think it's open source, an open source plugin for Word to be able to do chemistry stuff, which will be really interesting to find out what the process is about making plugins in .NET for Word and how that works. So yeah, that should be cool. So that's Monday, March 28th. And we mentioned earlier the AZ220 exam. If you're interested in going and learning a bit more about that, I've got a Pluralsight course that you can go and do that with. It's still up to date. The portal has changed ever so slightly since I made it, but it won't stop you from doing anything. It's all going to work just the same. So do go and check that out. It's well worth looking at. And then Cliff and I, as well as Maria Anastasia Mustaka, we in the past have run IoT Live, and this is coming back very soon. I've got a webinar that I've got to get done by the 6th of April, and after that, things will relax a little bit for me, and I'll be able to have a bit more cognitive space to bring back stuff like this. So keep your eyes peeled for the date when that comes back as well. And then the Agile Engineering podcast actually is going to come back soon too. You may or may not know, but I've joined Octopus Deploy as a senior solutions architect. So DevOps is part of my job. And I've always been part of the Agile Engineering podcast as well, with Liam Gulliver, Jonathan Relf, Louise Palin, and Misha Bell. And so that's worth checking out. We've got, I think it might be 12 episodes on there, and we're recording another one soon. And with that, we're back to the start, and I can stop talking and let somebody far more interesting start talking. So over to you, Cliff.
Second, I'm just making sure I share the right screen. There you go.
Hey, there we go.
So I got my friend's daughter, who's hoping to get into IoT, is hopefully going to be joining us shortly. She just asked me.
Oh, awesome.
So I'm not sure how many people we got on the call so far.
1, 2, 3, 4, 5, 6, which is quite low compared to the 20 odd people we had registered. So sometimes I wonder if there's been a problem with Meetup, but either way, you know,
that's what she was saying, is she couldn't get the link.
But you found it when you looked.
I found it, yeah, but I'm wondering if that's because I was a speaker or not. I don't know, but she was struggling to get the link, so I just pinged her the one you pinged me. So,
yeah, no, that's fine. Yeah. I'll check in the messages on Meetup just in case anybody's sending stuff on there, but no, usually you have to RSVP. It might be the problem is that if you don't RSVP in time, when the Meetup starts, the RSVPs close, and so then you can't get the link. So it's probably that.
Could be, possibly. We'll see.
Yep.
Anyway, while she's attempting to join, thanks for the intro, Pete. You all probably know me anyway. You know, day job is flying a plane. I'm off to Denver this weekend, which is kind of cool because I've not been there before. So I'm going to build a snowman, I think, in Denver. But yeah, day job is playing with IoT, mobile apps using Xamarin and Maui, and yeah, just generally doing developer stuff. I've been playing with the Wilderness Labs, Meadow F7 and ESP32s with Nano Framework for best part of a year now, for the two of them, if not a bit longer. And I just want to give a talk. So everyone I speak to about this is a bit confused as to what you can and can't do with them. And also, you know, a lot of developers don't know that they exist. So I just wanted to put a talk together. Now, the idea of this talk is, and the reason it's got called IoT projects is, those of you who know me, I talk about a prosthetic hand I built for a friend's son, Caden. And one of the ideas behind this is the fact that we want to put a small ESP32 or Wilderness Labs board in the back of Handy and drive servos, as opposed to these really expensive motors that are costing best part of $90, £100-ish, kind of give or take a bit, you know, time you add shipping and tax and everything else. So if I can take those out of the costs, we'll reduce the cost drastically, and we'll get the price of a hand with an arm and battery and all the parts you need, probably certainly less than £200, but I'm guessing less than 150. So the idea is that this talk is going to end with Handy working with Nano Framework or Meadow F7 running Handy. That's at the end of the talk, but I've not quite got there yet, sadly. But I'll explain where we're going towards this talk. But if you wouldn't mind, this talk I'm hoping to put out onto the conference circuit and go around and talk conferences and more meetups. So Pete was really kind to let me come along and test it out on you all. But if you can give me some feedback on what you think, yeah. And that's Summer Ferguson. Pete will be my friend's daughter, Summer. So yeah, you could let her in. That'd be great. So anyway, let's talk about using our .NET skills on small IoT boards. So if I get my slides to move on, I'm going to start because this is meant for a conference. What is a microcontroller? Because most people don't know what it is, but I'm assuming everyone in this call knows what a microcontroller is. You've got the microprocessor, which is the brains, the heart of your machine. But microcontroller adds on extra bits like the RAM, the input, output, the GPIO, input, output, and all the circuitry needed to make that kind of microprocessor connect to the outside world. But it's all very, very small. It's all embedded. It's got its bootloader loaded in RAM. It runs from that straight away, and you load your program into it. And it's unlike your kind of Raspberry Pis and your PCs and your Macs and your Linux, where you have an operating system that boots up and gives you a GUI that you then interact with the world. A microcontroller is all inbuilt into the device. Back in the day, and I was looking this up actually this morning when I was checking this slide. When I first got into playing with IoT, but there was no I then. It was just, everyone calls IoT anything that's electronics these days, doesn't they? Everyone says it's IoT because it's electronics, but I used to play with the PIC 16000 series and the Atmel AVRs. This is a really simple bit of C codes, which is literally looking at buttons, and if you push a button, it turns on the corresponding ports LED light. So you can look at that. It's C code, and you can see the DDRA data direction register A is set to zeros for input. Data direction register B is set to Fs, so all ones in that register. Set for output. Obviously, you can mix it, you can do bit banging and switch the bits live. And then you set the ports and you turn all the LEDs on initially. So you set the whole port B to 0, which turns them all on. And then you just go into a while loop, and depending on what pin is pushed, you turn on that port's corresponding bit in the port register. That's a really simple. It's called a simple C program, as you can see in the description at the top. But you start getting a little bit more detail into C code, and then you're starting to look at registers. These have got nice names like DDRA and DDRB, but you start looking at kind of complex registers to pull data out. Certainly when you get into things like I2C and SPI buses, the registers and that you're looking into, you've got to be careful about your timing, etc. So it gets really complex really quick. If you just want to do a hello world and blink an LED, yeah, go for it. These chips, you can actually, and I did check on DigiKey this morning, you can still buy the Atmel AVRs. And by mean you can still buy them, i.e. they're still in stock. They had something like 250 in stock this morning on DigiKey of the 328p, which is the one that I used to use quite a lot of, and I've got a box one still up there somewhere. Who else has thought about during this chip shortage of rifling through their boxes and selling it all on eBay and making a fortune?
I've got a load of Raspberry Pis. I reckon I could buy a new car with the Raspberry Pis I've got.
I was listening to Evan Upton the other day, actually talking about the Raspberry Pi and about saying that the issues they're having with the chip shortage, and the fact that they were selling around 7 million a year of Raspberry Pis to the maker community, and then an undisclosed number that they sell to commercial entities. And he says, and they're now trying to protect their commercial entities by saying, well, you've ordered 5, but do you really need 5? Can you get away with 1 this week and 1 next week, kind of thing. So he's had to take on a massive staff just to deal with that, just because of chip shortages, just because we all need them to build the kit. But anyway, that was back in the day, and by back in the day, when I looked this up, this is early 2000s, so not really that far back in the day. We was playing with actually wiring up these chips and building circuits and boards and breadboards and the like to make it all work. And then along come Arduino in the 2005, I think it was, from memory. And Arduino basically took those chips. You can see the Arduino Uno at the top left, and basically all they did was put a board around it and broke out all the pins and wrote a bootloader on there, so that when it booted, it actually interacted with the board around it. And that kind of started to make a community of people actually being able to hack stuff together. a little bit easier than actually trying to make a PCB. And it's gone on from there, and they've now got the professional series of boards. I've ordered a couple on pre-order. I'm still waiting for them to arrive. It's been what I think I ordered them September, October last year. So they're obviously suffering from chip shortages as well. But some of their boards are actually looking, pretty impressive, and still the cost is relatively cheap. An Arduino Unos are relatively cheap. We're talking less than £50 for these boards, and getting lower. Other boards that I use a lot of, because Arduinos I always found was a bit, too basic. I use a lot of Adafruit feather boards. In fact, Handy has got an Adafruit feather board sitting in the back of it, and that's what you use for operating that. I use a lot of the Tinsy, PRJC Tinsy boards, certainly the 4.1s, because it's got an onboard network port. You can see just there, those 5 pins there break out, and they give you take them up to an Ethernet port header, you solder it on, and you've suddenly got network capability from a board that costs, I think, £27. So it's pretty impressive what you can do with it. So the network port is them 6, them 5 are the USB. So you've got USB in there, and then you've got a network port header there as well. It's 600 megahertz Cortex M7, so a pretty beefy bit of kit for such a cheap price. But again, these run C, and just like the Arduino, they run Arduino C. And anyone that's done Arduino C knows full well that it's a cut down version of C. It's been bastardized quite a bit to make it a lot simpler for education, and it's fantastic use cases education, more in the kind of higher colleges and universities than in schools. But here you can see, in the setup, we just set up the pin mode 13 as an output, and then we do inside the loop. There's always a setting on a loop, and we set the pin 13s high, wait a second, set the load, wait a second, and loop back around again. And obviously, that's the hello world of every IoT project, and we just flash an LED. Again, so it's easier than what it was on the Atmos and the AVRs. So the Atmo AVRs and the PIC microcontrollers that we looked at a minute ago. So it's made it a lot easier to program and use. But you're stuck in this. You're stuck in the Arduino IDE. This here is, they call it a simple NeoPixel ring. It's an Arduino sketch. And all they're doing here is running NeoPixels, which are the multicolor LEDs, or a string of them. And they're just basically just iterating over those and changing the colors. But the Arduino IDE, the 1.8 series Arduino IDE, it's gotten better, but it's still effectively Notepad. When you open a new file, it opens up a new instance of the IDE. It's not brilliant. It's pretty poor. You've got no IntelliSense, etc. Has anyone here tried the 2.0 beta release of the IDE yet? No, I can't see anyone. No. It gives you IntelliSense. It's a lot better, but it's still, I go Notepad plus plus plus. It's still not a proper IDE the way it works. It's still, bare bones around it. I go VS Code is still better than V2 of the Arduino IDE. But if you're a Visual Studio user like I am, then you can get an Arduino, the Arduino IDE plugin for Visual Studio, which is called VS Micro. I've been an early adopter of this. I've got an early adopter license that is perpetual for VS19. The reason I haven't upgraded it to VS22 is because I have to pay for it then. But it's not that expensive. It's a fantastic team behind it. And it means you get all your Visual Studio tooling, all your key bindings that you're used to when you're doing your .NET code, all within Visual Studio. So you can do things like breakpoints. And the way the team have done that and given you a breakpoint within Visual Studio is they insert, when you put a breakpoint, it inserts at that point in the instruction set a wait, like a while one loop, which waits until it then gets an instruction from the system over the USB, which is you doing the continue. So you can put a breakpoint in there. You can't inspect an element in there, but you can do a trace. What that does is it reads the data from the memory and traces it out onto your debug.write line effectively, is where it puts it. Fantastic tool, highly recommended if you have to go down to Arduino C and play with boards that like the Adafruits and the PRJCs, or even the Arduino boards. It works for all of those. It's fantastic and a relatively cheap bit of kit as well. But we're .NET developers. We want to use our C# skills and .NET to use those skills and run .NET everywhere. This man, he stood up on stage at .NET Conf last year and said that .NET runs everywhere, and we should be using it everywhere, from device all the way through our PCs, up into the clouds, out to the IoT edge. We should be using .NET everywhere. But the problem is .NET doesn't fit onto small microcontroller boards. It goes down as far as a Raspberry Pi. So, we take a Raspberry Pi. This is an image of 4 Raspberry Pi 4. Good luck if you can find one. I'm working with a client at the moment, and they need 20 of them for a project, and they're struggling. They're buying them in ones and twos here and there to make the project work for them. If you do get one though, you can run .NET on it, and our very own awesome Pete Gallagher has got a great blog post at the bottom. And Pete, you still have your single line of code to install it all?
Yep.
You do? Excellent. That's in that blog post, isn't it?
It will be. Yeah, and in the GitHub repo. Yeah.
So yeah, you can run this single line and install .NET for you and get it all running and get it all installed. And that's awesome, because now we've got .NET running on a Linux-based machine. It's not a microcontroller, obviously a microprocessor, but as you can see here, it draws a lot of current. They say you should run a Raspberry Pi 4 with 3 amps power supply. 600 milliamps is its typical consumption when it's just running, not doing much, not powering USB devices, but just running 600 milliamps. So you're not going to stick that in a farmer's field running off a battery, are you, or a solar cell? It's just not going to work for you. So we, want to move away from these power-hungry devices. This would be fantastic for an IoT edge device. And they're the sorts of projects that I tend to use them on. Taking sensor data or acting as a node for smaller devices to connect to, then send it all up to Azure and into the cloud for processing and whatever back-end services you want to do. But if we look at that bit of code in a Raspberry Pi, this is now, we're in C# land, so we've got our using statements at the top. In fact, actually, we could probably take this into using no using statements and doing, what are they called? Implicit
global usings and top level programs.
Top level programs, and implicit using. That's it. Thank you.
You'd pretty much only get rid of using system if you did that, mind you, because you still need the other 2 usings. But yeah. But
you can go in and add the other ones to your implicit list.
Yeah, you're right.
So you could do that, and then when you do a .NET new, it'll pull that template in.
Yeah, we can try that.
Not done it yet, but you can do it. I've got a couple of blog posts where people explained it. So we are doing a lot of Raspberry Pi stuff. It's what I intend to do, is create a template for this client so that we can then just .NET new, and it will be ready to go with all the bits that we need, including some using statements for libraries they've built internally. But here we've just got a hello world, because we've got a console now, so we can write out to it. And then we're setting a pin, setting the time it's going to be a light for 300, so it'll be 300 milliseconds. We set the pin mode to output, and then we go around the loop, set it high, wait for 300 milliseconds, set it low, and go round and round again. And then there's closing. Pete, you should recognize this, because I took this straight from your blog.
No, not at all. No.
So, but it's it means that we've got C# on a device, but we're using that 600 milliamps plus a little bit more for an LED, just to blink an LED. It's a lot of power to blink an LED, isn't it? And yeah, the boards are relatively cheap. Around 45 to 50 pound mark at the moment. To get a board, and then you add power supplies and SD cards and all the other bits as well. But yeah, so what can we do to get .NET, this program, running on a microcontroller, running off a coin cell battery or off a USB port and drawing no power at all? We can use either Wilderness Labs or Nano Framework, and the title of the talk kind of gave it away. But these two are kind of battling in the same space. And as someone that works at this kind of low level with IoT, being a .NET developer, I'm intrigued and interested in both these projects. They're taking wildly different approaches to them, and we'll cover that as we talk through. But well worth looking at both of them and seeing which one works best for you. And if you come up with a solution or have thoughts on it, please, I'd love to know what you think about it, because I'm still trying to decide which side of the fence. I'm kind of sitting with these two as to which one I think is best. But anyway, let's pick the first one, the Wilderness Labs. They've got the Meadow F7 Micro, which is this board here. It's based on the Adafruit Feather system. So the pinout that you can see here, these pins here are pin compatible with the Adafruit Feather, which I thought was a genius idea, because it means you can go to the Adafruit store and buy any of their headers, their hats, and it will plug straight onto this board with no issue at all. And because all the pins are pin compatible. You got your ARM processor in the center, your STM32 processor in the center, and then you've got an ESP32 sitting out here. This section at the end here is where all the Bluetooth, Wi-Fi is done, and also the ESP32 is not quite there yet. They're at beta 6 at the moment, 6.01 I think it is, dropped about a week ago. And that ESP32 is going to be used to do over-the-air updates, so that you can over-air update your STM32 chip code using the Wi-Fi and Bluetooth and the ESP32 to bootload that code into memory. So, which is pretty bloody impressive, really, for a board at this range. You got your JST plug, so you can plug in your LiPo battery. I've run one of these for a couple of weeks just as a trial off a small LiPo battery, and yeah, it was quite happy just running there, just blinking an LED. So it was actually drawing current to blinking LED, and it just sat there for a couple of weeks, just powering a small LED quite happily. So yeah, fantastic boards. They're about $50, $50, ordered direct from Wilderness Labs, so single source supplier. Their V2 has just released as well a couple of months ago, and I think they've now got them in stock. They've not had them in stock for quite a while. That adds in, they fixed some issues with the board. A couple of trace points need to be sorted out. They fixed the battery charging circuit as well, because that had some issues with it. It occasionally didn't work. You had to cycle the battery and things like this. And they've added some other parts on there as well. They've updated the buttons that are on board the board. These buttons here. Because if you're a heavy user, the buttons break, and then you stuff the board you need put a new button on it or chuck it away and get another one. But the F2, highly recommend it. If you're going to buy one, go out and get one of those rather than the first version. It's got the issues. But let's look a little bit more deeply into it. This is taken from the Meadow website, or Wilderness Labs website. You can see the comparison they've got here, and I just like this slide because it compares the Arduino and the Raspberry Pi side by side. Now, I will caveat, this is done by for Brian and the team across at Wilderness Labs. So obviously they're going to pick that supported features list with their sales hat on, and they're going to pick the things they put all the ticks in and leave out the ones that they can't put ticks in. This slide this image has been around for quite a long time. Bluetooth Low Energy has only just been added in the last kind of 6 months-ish. It's still not fully featured, so they put a tick there, but it's not as fully featured as the Raspberry Pi one. But it works. I've used it, I've trialed it, and it does work. It's pretty good. Full .NET standard, I think you could put a tick in the Raspberry Pi box there, as we've seen from Pete in these blogs. You can stick that across there. Unsupported SDK for Arduino, yeah, okay. And some of the other bits there, curated hardware APIs. There's quite a few of them for Raspberry Pi. There's quite a few of them for Arduino as well. So I think they're missing ticks there. Otherwise, yeah, the rest of it is pretty good. The other thing about the Meadow F7 as well is they've now just released with the version 2. Should have said on the last slide, is a compute module similar to the Raspberry Pi compute module. So it's a more compact module with calculated edges, which you can solder into your device, and you can buy them much cheaper. I think they're down around the $25–30 rate if you buy in bulk, obviously. But this shows off some of the things that it can do with a Meadow F7 as well. We looked at the board before, but just this slide I thought was quite good because it shows you a bit more of the layout of the board. 16 meg of RAM. The V2 has got 64, I think it is now, but storage rather than the 32, which you see there. LiPo charger, your two controllers as well. There's some data at the bottom as well. Its JPEG image stuff is pretty impressive as well. I played with that. They've got a library you can download from their from GitHub to play with that. That's quite impressive. Doing the hardware image stuff. Downside is that they don't have a camera library yet. It's been in development for probably about 2 years. There's no camera library, so you can't actually capture the image. You can only read what you've got on device. So it seems to me a little bit, yeah, a little bit silly, but there you go. I just thought they put the work in the wrong area there. Looking at how this stack works, though, the background to Wilderness Labs, Brian, I can always get his name wrong, Brian Contash or Cotnash. I butchered it, but Brian anyway. He used to work as founding team member when Xamarin started up. So he's got a very strong Xamarin background, especially around the Mono runtime and the Mono framework, etc. So you can see here, you've got a micro RTOS at the base there. They use NUTX on the STM32, and he used 3 RTOS on the ESP32. So 2 different RTOSs are used. On the STM32, on top of the NUTX RTOS, which it's not the bog standard NUTX, it's modified for them. So they've got some more hooks in. They sit on top of that, the Mono runtime, which is exactly what powers all the Xamarin and .NET MAUI apps that are out there in the world. And then on top of that, because you've now got Mono, you've now got .NET and above with .NET Standard 2.0. So anything you do with .NET Standard 2.0, you can do sitting on top of that Mono runtime. But obviously, caveated with that is the fact that some of the things that you could do with the .NET Standard, some of the libraries you can pull in, may not fit on the memory because you haven't got that much memory. And also may not work because the device doesn't have that support. It doesn't have, whatever it is you're trying to do. Run some Skier Sharp library is just not going to work for you, is it? Because you've not got an output screen, etc. You can use like e-ink displays and LCD displays, but you don't really want to run a big library like that to manage it. And then on top of that, they've got Meadow Core, which is actually the core library. That's the bit you interact with. That's where you write your code. So you install the OS on the board when you get it. It's highly recommended if you do get a new one to install the latest beta versions. It's really simple. The instructions are on the website. I updated mine this morning to beta 6.01 or whatever it was. So yeah, it's dead simple to do. Meadow Core is all your normal GPIO access, etc., etc. And then on top of that, you've got the Meadow Foundation, which is open source. And that's all your libraries for doing things like handling servos or an LCD display, or someone's been writing this camera library for a while now. So all that is where you pull in the Meadow Foundation stuff. It's something you can pull in direct from GitHub, or it's part of the foundation. When you update your OS, it pulls down the latest bits as well. So just a quick demo for playing with that, and I want to that one there. I want to go out to the Wilderness Labs portal. If you're deploying the OS, so you want to get the Meadow OS, it's literally a .NET tool to install the CLI program, which pulls it all down and installs it all for you. And then you have to update the DFU utilities, device firmware updates, and you will find, as most people do, and I'm this bit here, they do this, and most people do this. It's like, well, this doesn't work. And what they fail to do is scroll down and look at the in-depth detail, which is below, which is why I'm pointing out to you all now. But you'll find that this DF util, if you've got a Windows machine, will have issues just because the Windows drivers don't work, and you have all sorts of issues. But we're back to this guy again, Scott Hanselman, and his magic. He's written a fantastic blog, which I always go and look for when I have to update my my utils and drivers. And he explains how you use Zagdig update all your Windows drivers and get it all working. But once you've done that, you can then use your flash the OS, and it flashes the Meadow Core and Meadow Foundation OS and that, and all the Mono bits. It flashes it down, to the boards, and then when you plug it into Visual Studio, it'll appear there and it'll be working. If we go across to Visual Studio, where's it loaded? Oh, it's over there. That's why. Go across to Visual Studio. You'll notice that not that one. It just has a program and a Meadow app.cs. So we look at the program. This is where we come in and start. It is literally just a console application, just like we looked on the Raspberry Pi earlier. So you got your you have a static app, and then the app comes in and it just infinite sleeps. That way the console program doesn't close. But it instantiates a version of Meadow app. That line of code there, anyone that does Xamarin program will recognize that is how Xamarin gets kind of pulled in. Your views and stuff are pulled in within the Xamarin app as well. We will go across to the Meadow app. You notice here I've had to edit this because I've only got a V1 board here. If you've got a V2, then you have to have it's called you put the state of the board there, so micro V2. So there was forward looking when they put this together, so they can change the OS, etc. You can see the foundation part is pulled in as a using statement on top there, and they've got an onboard LED which is RGB, red, green, blue, and they initialize the app. So we just come in here, we set the onboard LED. This is quite verbose. There's quite a lot here. You're doing things like setting the common anode and things like this. There's quite a lot going on in there. So it's, you know, first time you see it, you think, what the hell is all this? But, you know, you look at the docs are very good. It's very well documented GitHub repo. So you can look through that and see the samples and that they've done. And then all they're doing is they're just cycling through all the colors that the RGB LED can do. And there's some other bits here, color pulse and show color, etc. But that's a very simple program. Now, you'll notice here that in the docs, it tells you to get up the Meadow. So you go view other windows and you find the Meadow device explorer in here. Now, it doesn't seem to appear for me. I've tried it on 3 different machines today and it doesn't work. Device explorer there is the Nano Framework. Well, it's got the Nano Framework library. So I just can never get it to find. So if you right click up here, you should be able to find it was in here. Where's it gone? It's definitely there earlier. No, not that. Installed. Oh, you know why? I'm in Visual Studio 1999 instead of VS22. That'd be right. Installed it in the wrong one. Oh, in fact, that's probably going quicker as if I just installed it here as well, because I want it later. Now my mouse is there you go. Now my mouse is deciding it doesn't want to play ball. There you go. We'll install that and we'll close that down. Let's say that's the same, and we'll look in here, and there's Meadow application 2, and you can see now that when it loads, you've got this this toolbar at the top here. Like I was saying, if we just to prove my point, if you go out here, there's no Meadow thing in there. I've reported back to the team. Device Explorer is there for Nano Framework, and I could mention to the team, I think they call theirs Device Explorer as well, and I had the Nano Framework installed first, so I'm wondering if it's a clash of names and Visual Studio doesn't like it. But if you just right click up here, you can add the Meadow device list there, which means you can get your device. So if I plug in my Meadow, and if I go to my camera, wherever that's gone, it's there, and you can see I've got a camera off to the right, so we plug that in, and then we select the COM port and we literally click F5, and it is that simple. So all your normal F5 debug, etc., it builds out. First time you run it, it takes a good 3 or 4 minutes to run as it installs all the OS and does loads of parity checks and everything else. So it takes a long time to run the first time. But once you've got it installed once, it runs a lot quicker. he says. I'm a bit concerned the fact that he's still trying to connect to the Meadow on COM4.
I didn't see you praying, you see. That's the problem. I've not seen Shahid's magic smoke yet, though, so it's all good.
Yeah, that was a fun thing when that happens. Yeah, giving it my first NDC talk, it all goes up in smoke.
Quite literally.
Yeah. So why is it not connecting? Let's try this again. Cancel that.
Yeah, turn it off and back on again, yeah?
Always right. We start in the Meadow. She's not happy, is it? Just unplugging that wire, which is the servo, just in case the servo is drawing power. Not happy with that, is it?
Live demos. Not supposed to work, are they?
Well, I don't think they are they? Let's close these down because I want it to update VS19. Yes, I want you to modify it. Thank you very much. It's not happy at all, is it? Why is that?
It's beginning the communication process because it does actually restart the Meadow. You can hear it disconnect and reconnect. So it knows it's there.
Let me try. What I'm doing there is just down here, you've got to reset the boot button. So you hold down the boot button, click the reset, and let it go again. You can see here, my buttons are bent now. I've pushed them so many times. That's the issue, is they then short out and destroy your board for you. It's still not happy, is it? Not hot reload.
Try it in VS 2019.
Yeah. If anyone does talks, by the way, Mads has got a fantastic plugin that gives you presentation mode. So you set it up how you'd like it, and then you can literally set all the colors, the brightness. So you can see I'm a dark mode user, and my fonts are quite small in my codes, and it might not come across on a presentation. So in presentation mode, I've got it set with slightly bigger fonts and white mode, etc. And it doesn't mess with it doesn't connect to your account and doesn't mess with all your stuff. Yeah, let's try this then. If we add device list, COM4, try it from there. It'll be a very short talk if I can't get the boards working.
Live debugging. That's what we're going to do.
We'll live debug. That's what happens when you
No. Yeah, hive mind.
So it's definitely.
No, it's not.
That'll be why then.
Yeah, delete it. Click on it and remove it and unplug it and plug it back in and let it allocate again.
Okay, so it's definitely on COM4. We heard it bing bong. Let's try again then.
I don't hear it disconnect and reconnect in VS 2019 like it was in 2022. It doesn't even get that far, does it?
Find it on the COM list, is it?
Do a in Device Explorer, completely uninstall it and remove the driver, and then
just
in case.
Not that one. So what's that? That's the yeah. I know you've done it. Congratulations. Device Manager. This one here, and we will
didn't give you the option to remove the driver, did it? Oh. Oh, COM3.
3. Right. Good.
Is it in bootloader? No, it's not because you unplugged it. So it can't be in bootloader mode anymore.
Let's try it again then. No, Visual Studio's crashed. Oh, you got to love development work, haven't you?
This is where the client says, this is easy, isn't it? It's only a couple of bits of work. And you go, no, because you've got to deal with stuff like this.
Yeah.
It takes all day.
Yeah, the 20 lines of code I wrote were easy. It was all the other stuff that was, oh, well, I'm this is not going to work, is it? Select device. So, Meadow device list. The device.
Ooh. That's different.
I wonder.
Do you need a different lead?
That's what I'm just wondering.
I have this sometimes. I'm wondering if it's, programming it takes a bit more current. I'm wondering if that's what the problem is.
This is where I'm at the moment. So I'm just checking that I've definitely got all the pins in the right places. 5-volt there.
Wait, are you plugging it directly into your machine as well, Cliff? Or is it through a USB hub?
It's going directly into my machine.
Okay. Well, it blows that idea.
So, yeah, let's try a different lead. I practiced this earlier. I've got a spare one.
Always.
Always.
What Cliff is demonstrating here is a real life, essentially. And I think most people on this call will have played with IoT, if not doing it for their actual job. And yeah, this stuff happens all the time.
Let's try this again then.
Why is it not finding any devices? Yeah, that's not found it at all now. I didn't hear it bing bong when you plugged it in either. Oh.
Right, COM3.
COM3. Well, that's better. Oh. Hey!
There we go. Live debugging. We seem to have something now. Right, so as I was saying, you can see here, it's putting, it's got rid of it for me. Thank you very much. That's exactly what I wanted. I did want to show you all those files it loaded. You can see MS Core lib in there as well, and system.dll. So it's all in there. The other thing to notice is on the camera is this is the LED that's going to start changing color. You can see it's taken a long time for it to initially boot. This got me loads at the very beginning. You just got to just wait, give it a good 30 seconds. The first time you load it with any code, it takes an age, at least a minute before it starts doing anything, because it's the ESP32 and the STM32 are busy doing stuff. I don't think they call that out in the docs very well. So when I was first playing it, I thought my board was bricked, and I was like, there's something wrong with this and everything else. And I just, it was the moment of frustration. I pushed my seat back on the keyboard. And I was like, I give in. I don't know what it is. I can't work it out. I've been at it all day. And then the LED started glowing at me. And it was like, you just got to wait. Okay. But, we expect things on big computers, on big machines, just to happen quickly. And you've got to give this thing time. And because you've got no visual cues as to what it's doing, you've just got to give it time to boot up. But you can see here, there's our little onboard LED that we programmed earlier. And that's this bit here, and it's just going through this color cycle and loading it. So if we go back to the start window and open up this Nano servo one, we don't want to stop debugging. This one here, we've got a wee little servo, and this here is, I'm pointing at it and you can't see it. This little servo here, it's just a little 9G servo. These are the servos we're hoping to put inside Handy. Now, you've all seen Handy the hands, and in the back of Handy, this is the back of Handy. So this is the palm, and in the back here, you've got 4 motors. Now, the motors that we use at the moment are Actuonics PQ12s and the 12-volt linear actuators. and they just push out by 20 mil and then pull back in by 20 mil. And I've got an internal resistor, so you can resistor, linear resistor, so you can tell what the position is from the resistance change. So you can use that, but these motors are, you know, $93, $96, something like that. They keep changing all the time, and they're you know, not in stock that often. And on top of that, you've got shipping charges, tax, VAT, etc., etc. So they're quite expensive. To fit the motors, you need little metal dowels at the ends here to hold them in place. And you need little conical springs on the ends. You need 12 volts. So there's lots of things that rack up the price of handy. And most of the cost of handy is just purely the motor logic and motor circuit. If we can go to these servos, this servo here will fit inside there. And obviously you can see the scale there. It will fit inside quite happily and leave loads and loads of space for all the controller boards. That's £9 from Amazon, delivered next day. So we're getting the price point down massively, and we're just having to, at the moment, we're iterating this design in 3D in Blender. My eldest son, Macaulay, he was 26 yesterday. Happy birthday, Macaulay. He is busy working on the Blender files to make that servo fit inside this plate, and then we'll print it on the printers, and hopefully, fingers crossed, when I give this talk in the summer at a conference, we'll have handy working with a servo inside. But let's look at the circuits, software for running a servo. This is the Nano Framework one, so that's not going to load onto that board cliff. We want to go back to the start window, and we want the Meadow servo, that one there. Excellent. There you go. So again, looking at the program is exactly the same. Nothing changes there at all, and you very, very rarely have to touch anything in this program.cs. In here though, we brought in a couple of Meadow have got this units library. So rather than you having to think about degrees, radians, Celsius, Fahrenheit, miles, meters, kilometers, etc. They've basically broke them all out in this units library, so you can get the correct unit type and not have to worry about the fact that the type you're passing in is incorrect. We're bringing in some parts from the foundation, LED button servos. Meadow units again is being used as well. Again, I had to when you do a file new, it always assumes you've got a V2 board, because they want you to buy those, so you have to delete it up there. That'll catch you out the first time you do it. Instantiate a servo and a button, and then we've just got the LED just for a bit of showing the fact that the board's actually doing its thing. Then we create a servo. It's an SG90 servo, so just one of the normal 9G servos. We connected that up on pin 10, and we've then telling it to rotate its maximum angle, so it goes all the way around. Then we set up a button, and we had a click handler to it, and then we set the color to green. So when we see the onboard LED turn green, we know the code has gotten this far, and we've initialized the code, and it's just sitting there waiting then. And on the button click, we tell it to rotate to 180 degrees using the AU units, which we've got from up here, for angle units, and then we sleep for a second, and then rotate it back to 0 again. So if we load this is on COM3, we load that through boards, go back to the camera, and I just need to plug this in on pin 10, which is that one there. And we're just waiting for this LED now. Obviously, the code is loading, waiting for that LED to turn green. I'm just going to make sure that it's doing its thing. It's restarted and build succeeded. So we can go back to our camera. Look here, and we just, like I say, we're waiting for it to load and to do its thing. I'm waiting, impatiently waiting. Sing to yourself, hum maybe. There we go, light's gone out. Come on, you can do it. It's gone red. There you go, there's green. Right, so you can see there, it turned red when the LED was initialized. It initializes on red. You can then see it turn the servo to its max angle, so it turns all the way around. And then if we touch the button, it turns 180 degrees. And a second later, it should turn back, but it didn't. It turns 180 degrees and turns back again. turns 180 degrees and turns back again. And that's quite simple. This is just a crude tactile button. So their button library is doing all the button debouncing for you on the input, and taking care of that for you. It's taking care of talking to the servo for you. And I'm driving a 9G servo via the board, so it's got enough current to drive one, but just one. Don't push more than that, otherwise you end up with a broken board. Ask me, I'll know, because there's one over there. So yeah, that's why this board, for me, the fact that you see the blue headers here, you can drop on top of that the Microcontroller board from Adafruit, and I've got one. There's one over here somewhere. I've got one there somewhere. I should have got it out earlier. But Microcontroller board drops on top, and then you have from that you can drive 4 servos or motors. In fact, actually, if you wire it correctly, you can drive 16 servos from the one board, and it costs £18. You can get it from Amazon. And that just plugs directly on top, which is kind of cool, because it means you're using the device, and then you just wire up 5 volts to that. And it will draw a couple of amps or whatever it needs to drive out those servos for the few seconds that it needs it on the pulse width modulation that it draws the current. So you can see there, Meadow is, it's quite intriguing to look at and think about. My concerns about Meadow is it's a small company. Their sales are getting better, but it's still quite small and niche. When Scott Hanselman stood up on .NET Conf, he talked about Nano Framework, didn't mention Meadow, and he's been a big person behind Meadow in the past. So I hope it doesn't go anywhere. I hope they succeed. But at the moment, using it is just forgetting the hardware is a bit concerning for me, just because you don't know they're going to disappear next week. Hopefully they don't. Hopefully they'll get some backing and make this work. But it's a really interesting project to keep an eye on and watch. So we go back to slides quickly. Where are they? There they are. And we'll move on, and we'll talk about Nano Framework. The good thing about Nano Framework is the fact that it started out with the Micro Framework back in the day, and then a team have taken it over. We've had on IoT Live, we've had, I've forgotten his name, Pete, I can't remember his name now. Pete will remind us when he comes back in a minute. And you got Ellerbach, Lauren Ellerbach as well, who's a Microsoft's employee that works on the .NET IoT side, so more of the Raspberry Pi and upwards and the likes. But the Nano Framework can run on a lot of boards. There's just some samples here. You've got ESP32 family of boards in the top left. You got the STM family of boards in the bottom left, and up on the top right as well. You've got the ESP30 board, which is the microbits one using ESP32 chipset. And also, because it's open source, there's community editions of these boards as well. And there's a Raspberry Pi community edition for running Nano Framework on a Raspberry Pi Pico, which is a $4 board. Actually, they're £3.60. I see earlier on Pimaroni. So you can get one of these boards super cheap. So we go out to Nano Framework, and here's the Matthias Castello has got .NET running on a Pi Pico, and this is how we set it up using UTF files. There's a little bit of jiggery pokery. You need a programmer to make it work. These are fairly inexpensive little doohickeys. There's one there. And these are just a few pound on likes of Amazon and Pimaroni, just an FTDI programmer. You can get them in cable form as well. I've used them in cable form where the chip is actually embedded in the cable. I use some of those when I'm working out on site, because this thing just gets broken really easy. And the downside is you need a USB-B plug. I'm showing you this, and you don't even have the camera view, do you? There you go. There's the board and the chip, and it plugs into your board using the pins, and then it's got a USB-B plug on the end. And the difficulty is finding a cable in your drawer of broken dreams that still fits USB-B. So that's a fantastic project. I've not tried it yet. It's still being built. and it's out there on the GitHubs for you to go and play with and look up. So if we go back to the, where's my slides gone again? That one there. And so Nano Framework is basically allowing you to run across all these different chipsets. So you've got a whole host and family of ESP32s and STM controllers as well, which means you don't need to worry too much about the hardware. I mean, these ESP32 dev boards are like, you can get 3 for like £10. ESP32 cams, I think I paid £15 for 2, and they've got a camera on board. The STM chips, these are a little bit more expensive, but you're still only talking £15 to £20 for these little M5 boxes. So, hardware you don't need to worry about because it's expressive, and STM are not going to go anywhere. And Raspberry Pi are definitely not going to go anywhere anytime soon.
Is it on the Pico now?
Sorry? Is
it on the Pico now?
Did you not listen to my 5 minutes of talking?
No, I had to go upstairs and say night to the kids. So I'm sorry.
Oh, right. Okay. For you, Pete, we'll step back in time and pretend I didn't say it. But yes,
I missed that.
Matthias Costello has been building it out. He published his blog last year, summer last year, and this explains it. But he's built it out even more now. Whereas before he just had GPIO, he's starting to add other things now, like SPI buses and stuff like that. So yeah, it's pretty impressive.
I've spoken to Matthias before. He's done some awesome stuff actually. So that's really impressive.
Pretty impressive blog to watch. But if we look out on the documentation on Nano Framework, you can look at the devices, and these are all the libraries that they've got. And you think of that just like on the Meadow, it's a Meadow Foundation. And then in documentation, you've got ESP32, STM32, TI, and NXP. So you've got 4 manufacturers of boards there that you can run the Nano Framework on as well. So it's pretty impressive. I don't think you're going to have hardware issues anytime soon. How does it work though? It works differently, very different actually. You got your hardware layer at the bottom, which is whether it's STM or ESP or Raspberry Pi, whatever chip it is, it runs on. You got the abstraction layer, and what that abstraction layer is the code that is making when you talk to a GPIO pin on the ESP32, you're toggling that bit in that register in that part of the memory. When you do it on STM, you're toggling that bit in that register in that part of the memory, and obviously different. So the hardware abstraction layer is mapping those back to the platform abstraction layer, which is where is the next level up. And what that is then exposing those out to the .NET CLR, the Common Language Runtime, which then means you can build your code on top of that. So you got a very vastly cut down CLR, because obviously you don't need all the things like monitors and stuff like that on there. So it's cut down quite a bit, but it's still .NET Standard 2 to a degree. And MS Core Lib is still sitting there, and .NET and the other namespaces. The way Nano Framework works is they map, or they're trying really hard to map one-to-one to the .NET, .IoT, devices and framework namespaces. So if you do .NET, .IoT as a namespace, or system.iot, I think it is, isn't it, Pete? They're trying to map one-to-one to that. So when you put it into your NuGets to search for something, just put Nano Framework at the beginning of anything else you see, and there'll be a library that you can use for that. A lot of it is being rewritten at the moment. So a lot of the libraries, a lot of the core parts of the hardware and platform abstraction layers have been rewritten recently. So if you used this a couple of years ago, it's vastly different to using it now. It's a lot more stable. And the Visual Studio tooling is even the library out for VS22 in preview at the moment. I've been using it, and it's pretty solid. There's a couple of little gotchas. I updated this morning. Nordic Wirecoms disappeared from the device list. The team are aware of that, and they're going to fix it. Obviously, they've regressed that somewhere. But again, it's different. So with Meadow, you had mono and access to the whole of .NET. With this, you have just access to the bits of .NET that they give you access to, the bits that they've written the library for, and part of the abstraction layer under the CLR. So you're kind of, you feel a little bit more hemmed in than with Nano Framework you do on the Meadow, but you're less hemmed in with hardware because you've got more choices of different devices. Just simple things like an ESP32 you can put to sleep and it draws nanoamps to stay in sleep mode, and that is just a clock cycle to wake up at a set time. You can't do that with the Meadow, even though they're talking about getting it down to a few micro milliamps for running the Meadow in sleep mode. But you've got 2 chips on there, so little things like that are kind of keeping me on this fence of trying to decide which way to go. I'm planning to use this expressive dev board version 4, and there's the pinout. So I wanted to highlight this. If you use any ESP32s or any IoT board, but certainly ESP32s, a lot of the pinouts are not 1-for-1. Like your GPIO 9 there, and it's got D2. This board isn't so bad. But quite a lot of the boards are the pin numbering that's on the board doesn't match the GPIO pin. The number is for some other reference, like the ADC number or something like this. So if you are going to use ESP32 boards or an STM, just look at the docs, look at the data sheet, and look at the pinouts, and make sure you. I prefer to get the color ones because little things like this, like the fact that they're dark, means they're input pins only. You get used to how expressive draw their diagrams and what they do. So you can see that's it's input only. It's dark there, and it's got an arrow in, which has got a wiggly sign, means it can do PWM, it can do input output, real-time clock signals, and all sorts. Just be very careful as well, because some of the pins have these marks here. Just saying that they are being used by other parts. So I know that this corner of the board here is being used for the SD card. So obviously you don't want to mess with that and start putting your pins on that. And then it's got internal pull-ups and pull-downs and the likes as well. So it's a fantastic board. Again, I think I picked up 3 of these for less than £10 from Amazon. I'm not sure how Jeff Bezos managed to get these from the other side of the world to my door for £10, but hey, he managed to fly almost to space with the money I gave him. So hopefully we all buy a few, you can maybe make it to space.
Pretty much just you as well, I think, Cliff, or perhaps me and you. But
yeah, maybe, I don't know. So my wife certainly has helped him get to space, I'm sure of that. Well, almost to space anyway. So I was going to run a demo, but as people will know, I've been having all sorts of issues with drivers because the PC that I'm talking to you on is Windows 11. And it's had all sorts of problems with drivers for updating the boards. The way you work with Nano Framework, we go back out to the getting started, is where's it gone there? Getting started. The way it works is it's in here somewhere. You have to install the library in Visual Studio, and they're obviously promoting the one for Visual Studio 2022. And then you use a library called Nano, which is Nano bootloader library. And you have to install, you remember on Wilderness Labs, we talked about the fact that you install and you flash the OS, etc. That's what this Nano tool does, is Nano Framework Flasher. The library is actually better than the thing. So you install the tool, and again, it's a .NET tool, so it's that line of code there. If you want to, or leave off the path if you don't want to install it in. You want to install it in the normal .NET location, and then a simple update there as well. So all the normal .NET bits work for it. And then the libraries, it's quite simple. It's you basically tell it you want to update it. You tell it the target. So if you know the precise target, you can give it a precise target. If you don't, and it's just an ESP32, and you're not sure, just put -- platform ESP32, and and what it does, it interrogates the chip and asks the chip. It takes longer, but it interrogates the chip and asks the chip, what can you do? And then based on that that data list it gets back, that table that it gets back from the chip, it then says, okay, the best OS for you is this one, and that's the one it gives you. You might lose some functionality of the board, but if you're not sure which one, that always works. It's where I start. And then if you can work out what the actual chip is that's on board, you can then and what target you want. There's a list in the GitHubs here, so you can pick out your target and narrow it down. If you're missing that little thing, I was working when we did the flight into IoT. We needed to use a lot of memory, so we needed to use the PS RAM, and I'd been using the platform ESP32. And the chipset that I was using, the ESP32 CAN board, wasn't reporting that it had PS RAM on board, 2 megabit, even though it did. So I then found the correct target, loaded that, and then suddenly all my code and access to that memory was available. Then you just take the port, and then it loads up the OS, or the Nano Framework OS, onto the board as well. So that gets us to that. And if we come across here, we unplug this, and we get rid of this board, and we bring across this board, which is our ESP, across there, ESP32 dev board, dev chip. I need to just wire these up. So I've just got power and ground, and then I want, actually I don't even need that because I'm not using that daughter board because the servo is not going to work for me. But if I plug this in and then go back to this, stop that because obviously it's not plugged in anymore, and we go back to the start menu and we do servo one in here. So looking at the servo software, and you can see the LEDs blink, LEDs on. I didn't have it blinking. I didn't have time to make it blink. I had to write this code on a Windows 10 machine. So I did it on my son's laptop earlier, and then loaded it onto the board. So that's why I can't run it here. But if we look back at the code, here we are. You have to. Why is Visual Studio decided that? You bring in every using statement. So you can see here IoT.device. That could be a .NET library or the Nano Framework one. So it brings it in. So when you go out to the Solution Explorer and you look at your NuGet packages, you will find that they're all Nano Framework dot is what you need to put into. So if you put in, you're looking for a library, it always starts with Nano Framework. So if you put in one like system.device.gpio, there'll be two of them, but one of them will be Nano Framework, the other one will be the .NET library. So make sure you get the correct one. And then you need to put everything you pull in via NuGet. So if you want a button, you have to pull in the buttons library. You want a servo motor, you pull that in. So it's a little bit more work than the Meadow and full .NET, obviously. But it means, and the reason they've done that, and I was a bit miffed by this at first, but talking to the team, the reason they've done that is because if they pull everything in, it bloats the OS. And when you work on a small board with no memory, it makes it too big. So they took the decision, I think a great decision, of you pull in just what you need. So if you need to use a button, pull in the button library. It's only a few lines of code, but it bloats that memory. So then that's what you're doing. We just create a servo, and we can still do debug write line, which writes out to the VS Studio console. We set the pin function at the PWM. So I did want to use pin 13 for my PWM, and then we set up the channel PWM at 50 Hertz. We set the servo motor, which sets angles and the frequencies that the PWM is going to work on. We start the servo. We set up a button on pin 36 because that's one of the input ones, if you remember. We set up the button event, and then we just set up an LED, and I just set the LED to high, and that is again a bit like the Meadow, where the onboard LED turned green. I use this quite a lot in my programs, just so I know when the program's running. It's the last thing that is actioned before we do the infinite thread, which stops it going to sleep. So when the LED's on, I know that the code is running. And then all we do is you push the button, it sends it low. It's the LED, it turned it off, so we know the button's been pushed. It sends the right angle of so servo.right angle. You just write the angle when it goes to something at 90 degrees. Wait a second, it went back to 0 degrees, and then you set it back to high again, and the LED come back on after the thing. So again, C#. Not the same as Meadow, but this is, we're in a static main void. All your normal things can work in there. But because they've rewritten the CLR, you don't have things like generics. You don't have async await. You have those on Meadow, but you don't have them on Nano Framework. So if you want to do like link, and you want to do generics, you want to do all those sorts of fun things, your .NET code is not going to work in Nano Foundation, Nano Framework land for you. So you just need to keep that, keep that in your mind as well. It's coming. I've been told by the team that they're working feverishly in the background on bringing generics in, early generics. You know, think .NET, is it .NET 4? I think generics was brought in, wasn't it? .NET 3, .NET 4 timeframe. Can't remember now. It's going to be similar to that. So not quite the full feature that we have now. Again, because they're thinking of running this on a small device with not a lot of memory. Meadow, because they control the hardware, they know what they can do because they control the hardware. So this is the software which runs here. Now, I know what you're thinking now. You're thinking to yourself, well, Cliff, you know, this is great, but, you know, we've got this IoT, and the I stands for internet. None of this is connected to the internet. Well, both have Wi-Fi. If we look at the why is my mouse playing up today? Device Explorer, we've got our device on COM5 there, and we can send out the program, but I know it's going to crash, so I'm not going to do it. But if we look at device capabilities, not device capabilities, sorry, network configuration, so we can push that, and hopefully it's not going to crash. We can set up the network configuration in here, so set up our network interface, Wi-Fi profiles, you know, all those sorts of things we can put in there. And in general, we can load certificates, so root certificate and device certificate. So we want to connect up to Azure IoT Hub. That's where we'd put our certificates, so we don't put them in code. And these are stored on chip in a secure location, so that you know, our certificates are there. We've not got them in code. So you're not committing your certificates, certainly your device certificate. You don't want to commit that into GitHub. So you'd load it into here, and then when you get your file, you can burn loads of chips with that. Obviously, you don't need Visual Studio. Just burn loads of them from that Nanof tool as well. You can just have your file, and you can just leave Nanof burn. You can burn loads and loads of chips all in one go. So that's where you do that. If we look at a slightly more complex project, then this here, not that one. Where's it gone? Tech Day solution, and Pete and Sander will remember seeing this. This is a much bigger program, and this runs on the ESP32 cam. I need to grab the right one, which is that one there. So that bing bong you just heard is me plugging in that there, which is an ESP32 cam. It's got an SD card in the end, so we store files on the SD card. If you get these, you have to program them with that FTDI programmer that I mentioned earlier, or you can use this. I get them with this motherboard, which has it built on. It's literally 50 pence more expensive, so I use those. And then what we do is we set up our device provisioning service. So you can even use device provisioning service from Azure IoT. And we set all that up, and we can set up our data models. So again, you've still got all your classes and your data models that you can use. And my mouse seems to have given up the ghost. And then in main, we're connecting to the Wi-Fi and reading the data out from JSON packets. So we're reading the JSON from the SD cards because we couldn't fit in memory, because this was a 3-hour show of data points of where an aircraft was traveling across Europe. And we've got a direct method call we can call from Azure IoT Hub, and then we can you know, all the connection stuff is here. So we go out to on this computer, it should go to the correct one. It does. So we go out here and we look at the it's moved. It's device provision service. Why? This one, we look at devices when we set this up, and this was all recorded on GitHub if you want to go back and watch it. But we've got a Nano Framework device. My mouse is really having a bad day today.
I've put the link in the chat there to the recording.
Go in here, so and then we can open a direct method when my mouse picks up, and I've forgotten what we called it now. We called it, the direct method was called change flight status. So we can action that direct method, and I know that it was called start. So we can literally send that command. So we invoke that method. We'll notice that it does some stuff. My mouse is, so I'm going to give you feedback. And it's fouled just because the demo gods don't like me.
They don't like you at all tonight, do they?
Don't like me at all late at day. What that should do is call that flight status and the string payload, and then it looks for start, which is there, and then it actually starts to work a thread, which then kicks it all off. And you've still got threading in Nano Framework, but you just got to do it the old-fashioned way. So it starts that worker thread, and then it will start running the code and start doing stuff. And I don't think it's happy. Don't think it's worked for me.
Feels like maybe it's not connected to the Wi-Fi for some reason.
Yeah, it might still be booting up. The ESP32s take quite a while to boot up, but I would have thought it would have been booted by now. Give it one last try. If it doesn't work, we'll move on.
You definitely registered that method name as the callback, did you? Yeah.
Yeah, it's all registered. Yeah. Well, I cut and paste it from the code, so
you pasted the method name, but you have to register that method, don't you?
Yeah, that's registered. That's registered there.
There we are. Yeah, cool. Yeah.
Not sure if it's. Let's look at the device twins. It's not happening at all, is it? 17th of the 3rd at 2 o'clock. So yeah, it's not updating at all. It's not happy. That was when I was testing it earlier on today. But it would start it, and then it'll start sending out telemetry and connecting. So it should connect to the device provisioning service, provision itself if it's a new device with the names it's given, and then start uploading the data that's currently just got on the SD card, but obviously it'll put it in from sensors, etc. So that's what you can do. So you can connect to the internet and send lots of data. This ESP32 CAN board will run for weeks on a small LiPo battery. So I've done that and to test it for a project I'm working on for a client. So yeah, this, those little boards you can put them to deep sleep, and they'll run on literally no power at all, and wake up on a real-time clock at 1 o'clock every day and send data that it gathers from the sensors at that time of day, and then go back to sleep and wake up at midnight and do the same again. So that is my demo for that, and I just want to say thanks. And if anyone's got any feedback other than the fact that I need to go and shoot the demo gods, I'd be greatly appreciative. Thank you.
Very good. Thank you very much.
I'll stop sharing my screen. See if you can have it back, Pete.
Yeah, very good.
That's annoying. That's why that's not worked.
Yeah, I don't know. Unplug it and plug it back in again and try it again.
I've tried that.
Oh.
We'll give it another go. While we're talking, I'll see if I can get it working.
Yeah.
I can, yeah.
Your camera goes funny every now and again as well, Cliff. It seems to think you're in some strange rave.
In the background. Yeah, I've ordered a new camera, but just like everyone else in the world that's working from home, they've all ordered cameras, haven't they?
Yeah.
Hey, Summer.
Hi, Cliff. How are you?
I'm good, thank you. I'm good.
Good.
One of my close friends' daughter, and she's studying engineering and IoT, aren't you, at college, I believe?
Mechatronics is what I'm studying at the moment. Yes.
Yeah.
Yes.
Nice.
Yeah. So you'd love the hand then, wouldn't you?
I know. It's glorious. It's lovely.
I'd love to send
you I know. Every time I come over, I don't get to see Handy. I meant to show him the last time, and I didn't get to see him.
I think your dad's planning to come over in the summer this year, so
I have to sneak on with him.
Yeah.
Have to sneak on with him.
Yeah. So Summer's trying to learn more about IoT and get into Agile IoT as well. So Pete's the person to ask. Pete and Sandra have got all the answers to all the Microsoft exam. So if you speak to them,
Perfect.
They'll give you the answers to the exam.
You don't need to do that. You just need to watch the Pluralsight courses because, well, at least my one was written by the person that wrote half the questions. So that's a good place to start.
Perfect.
If you read all my blog posts, then you get all the answers.
Happy days. Good.
Yeah. The Pluralsight course, Pete and Jürgen and that put together pretty impressive actually. So yeah. So actually, Pete, have you not got one of your 30-day pluralsight thingies?
I need to go back and ask them. They decided at one point they weren't going to do that anymore. But I need to go back and speak to. I've not spoken to them in a while because I've been doing other stuff. So, they used to give us a bunch of full access 30-day codes. So yeah, if you're interested in one of those, then absolutely, I'll go ask. Drop me a tweet or something, and I'll send you a DM, and you can. I'm sure we'll be able to get some.
Awesome, perfect.
No worries.
Thank you.
Where's your accent from, Summer?
Northern Ireland, the good old Northern Ireland, yes. And everybody's off for St. Patrick's Day today.
Exactly. All my family's from Donegal.
Donegal, beautiful. Yes, lovely. I know, because there's certain. It's a public holiday here, and most places people get it off, and obviously anybody who works for government stuff gets it off. But we're still working today, so not all of us get that luxury, unfortunately.
Gutted. I'm looking forward to having to be over in middle of April. Can't wait. It's been 3 years since COVID, so can't wait.
Yeah. No, well, hopefully the weather picks up. It's been pretty miserable. Miserable.
Well, it's not Wednesday, the 2nd of June, you see. That's why it's not sunny.
Yeah, I know. But see, last year we had a really, really nice sort of March coming into April, and a nice sort of graduation into the springtime, but obviously not this year. It's just been turning down, just constant rain. Horrible.
So has anybody got any questions for Cliff other than why didn't the demos work?
I've got a question. Why are you using C# over? What's the advantage of C# over C language?
Over using Arduino C, just because I've been doing .NET and C# for so long now that's how my brain works, and to drop back to C just always feels I can do it, but I just prefer working in .NET and C#, and I'm just intrigued by these 2 different platforms and how they're coming along. I'm not using them in production. If I'm doing stuff for clients, I'm still working in C, but it'd be nice in in a year or two's time when these are actually kind of stabilized a little bit. Certainly when Meadow gets out of, it seems to have been in beta since forever. Yeah. It's a beta 6 at the moment, but when it gets to release, or at least RC, now I might take it a bit more serious as to actually let's use it. We've had Brian on the IoT live show, haven't we, Pete?
Yeah, Brian Constantine. Yeah.
Who's the one that does the Nano Framework? I've forgotten his name.
Isn't it Simone something? Oh, my memory's gone.
I can't remember, but yeah, it is Simone's. Yeah.
Is Meadow does the framework? It's only in C#. Or does it? Can you program
any of your .NET languages? So you can C# it, F# it. If you want to go and use VB.NET, then fill your boots. Obviously, that's not fully supported because they've gone the C# and F# route. But yeah, if you can compile it on top of Mono, then yeah, you can use it. Which for me, and the fact that you can use the Adafruit boards is pretty impressive. It's just I worry that the hardware vendor might not be there in a couple of years' time. That's my only concern.
Jose Samores is the name. Geez, brain fade of the .NET Nano Framework creator, and yeah, he was along with us for Flight into IoT as well. And one of the big things they're trying to solve with allowing us to be able to program C# on devices like this is to stop siloing dev companies. So getting a competent C programmer is quite difficult. And so they tend to fit into a certain slot. Finding C# devs is way easier just because of the number of them that there are. So if you imagine that you've got the GUI folks and the web front end folks, they can all do the same stuff if you can do it in C#. It's got a way to come, as Cliff said, but that is the hope, that we can democratize IoT and take it out. The other thing is that the college level and below, trying to teach folks C is hard. C# is a lot more approachable than all of the stuff that goes with it. Arduino C is not too bad, but you go any further than Hello World and you start getting into a world of pain quite quickly. And certainly one of the things Cliff and I are trying to do and hope to do is to be able to involve kids in IoT. If we can catch kids before they're 12 the work that the Raspberry Pi Foundation are doing, and Code Club, and fantastic organizations like that, are proving that if you can catch kids before 12, then we don't get so much of the drop off. And certainly with girls at that age, they tend to drop off faster, and that's a big problem. I've got two girls here at home, so making sure that this is an open community for them as well is massively important to me. So whatever we can do to make it easier is the bulk of that story.
At the moment, I mean, Arduino and Raspberry Pi, they're switching everything to Python. Even Arduino now switching to Python.
MicroPython.
Great, because it's easier for kids to learn. I mean, my two sons are doing Python at school. But the problem that I've heard Scott Guthrie talk about and mention on the talk is their concern is the fact that Python kind of tends to lead to Java world and JavaScript, which tends to lead to, you know, front-end developers and stuff. So their concern is the fact that back-end developers won't, you know, C# and .NET, they see it as a challenge. I was quite intrigued by that, and I thought, well, if you see it as a threat to .NET, hopefully they're going to do something about it. And you know, things like top-level programming takes away all that cruft at the top of the file, makes it easier to learn. When I first see that, everyone was like, "Oh, what are you doing?" But it makes sense to me to teach a kid that in a single line, just write console.writeLine and what message you want it to be, and it'll appear on the console. That's one line of code. The fact that before it was probably about 30 lines of code before using this, and you know, static void main this and everything else. You know, no brackets, get rid of it all. It looks more Python-y, which is easier to teach. But yeah, I think there's a long way to go with .NET and IoT. It's still, for me, it's not quite there. I'm not prepared to use it on a production app or production project just yet, but it's getting close. I'm just not sure which side of the fence is going to be better. I'd like to use Meadow purely because it's got mono and kind of the Xamarin, and I do Xamarin stuff as well for mobile. So I feel very happy in that world. I know how they work and think, but I just, you know, I worry about the hardware vendor that's behind it. You know, if they had a big company backing them, you know, I'd be behind it. Nano Framework's part of the .NET Foundation, so they're secure now. So if the leads like Jose Simone disappears next week, we've still got the support of the .NET Foundation as well, which is kind of cool.
Yes, all open source. I mean, the Meadow's great. I like that coprocessor idea, and I think you can open that up. You can program both, can't you? And offload things like perhaps AI TensorFlow stuff to the ESP32. Yep. And yeah, this kind of feels a little bit like what's good about the Pico as well, the Raspberry Pi Pico, where you can offload some stuff to I forget what it's called now, but it's got a special.
Yeah, it's a state machine called
yes.
PIO, isn't it? Yeah,
that's it. Yeah, so stuff like that I like, and yeah, I like the fixed nature of the Meadow. ESP32, you can buy the same one twice from Amazon and not get the same one. So repeatability is really difficult unless you're going to go and source the chip itself and build your own boards, which really is what they want you to do, I think, ideally. But then you're into talking to China to get boards fabbed and stuff like that. So yeah, all of that.
Yeah, cool. What's the link in the middle? The kit in the middle link is cool.
Oh yeah, I should have. That was supposed to be a private message back to David and I talking about kits and the IoT stuff that we can give away. We're just busy looking at. I mean, what I'd love to do is be able to give Raspberry Pis away. But if you have a look at the Pi Moroni and Pi Hut sites, basically every single Pi other than the Pico is sold out.
Yeah.
So it's something Cliff and I are going to talk about as well as David. I kind of like the idea of the speaker choosing the kit, because it kind of goes with whatever their talk's going to be, but we don't always have that opportunity, to be fair. And the Meadow, we have to, don't we import it from Adafruit? I think that's what David.
Meadow comes in direct from Wilderness Labs, and it was one of the things. I'm not sure if they've got them in stock again.
Right.
Yeah.
There's an import duty to pay and stuff on that. I think that's what David was a bit concerned about, and not wanting to land people, because the idea is that we'd send it straight to people.
No, I don't think there is, because it's a I don't think there's import duty. There's just the no, I'm pretty certain there's not actually. I'm pretty certain I've not paid duty. It's just the taxes and stuff.
I think anything under 50 quid's free anyway or something, isn't it? Or is it 25 quid or something like that? I forget now. There's a limit though, isn't there?
Yeah. But that was what I was going to suggest was a Meadow F7 V2 dev kit with the little coffee thing on the base. I literally, when I first got mine, I thought that was a coffee coaster. So I was using it as a coffee coaster, which is why the middle of the tree's gone. And it was only when I see Brian talking on a meetup, and I see the fact that he built his board, I was like, that's why there's all those extra screws, nuts and bolts and stuff. I get it now. It was for the first kind of few weeks. I was using it as a coffee coaster, but there you go.
Well, we can offline about that anyway.
That was my suggestion as something. It's $50, so it's within the £50 limit. Even with shipping, I think it come within that. I think the shipping was, I can't remember now. I'm just looking at it at the moment, see what it comes out. I think it was still within it.
Yeah, we've got to give some thought to folks that may well be joining from outside of the UK as well, Sander? And how we get stuff to you, if at all. I know certainly folks like Microsoft just don't do it, but I give it some thought.
You can bring it.
Yeah, I am going to just do that, because I want an excuse to come across, and I'm going to get like Cliff to fly us. He'll have to go a long way round because he doesn't do short haul. But
maybe airdropping.
That might work.
Yeah, we'll check it out.
Yeah, parachute.
Pass. Yeah,
that'll work. So we're not going to draw it tonight because we don't know what we're drawing. But in the next few days, we'll decide what it is we're going to give away. And as long as you've tweeted on the hashtag #NotsIoT, there's a good chance that you will win £50 worth of IoT kit, courtesy of Calyx. And in fact, David, while people are still here, did you just quickly want to say what it is that you are doing as our new sponsor? Did you want to quickly tell people what it is before I turn the YouTubes off?
Next time. I'm not prepared.
I'm sure you know at least what the company does.
I do know what, but I can do something a bit less off the cuff.
Yeah, that's fine then. Yeah, no worries. So it's all good. So unless anybody's got any more questions, I'll turn YouTube off.